guys, welcome to tutorial 3 and the network reduction. In this tutorial, we are asked to calculate Ix and the total power absorbed by the entire circuit. Ix and the power absorbed by the entire circuit. We are given a number of resistors, which is there are 5. Some of them are connected in parallel. We are also given I naught to be 3 amperes. And we can say that I naught is what on this branch. That's the current flowing through the 16 ohms. The current here, and here were not given. We also given Ix to be what? The total current that was coming inside the network. So Ix will flow through the term. It will flow through this term on this branch, then it will get to what? This junction. So when, as we said in the previous videos, when current gets to a junction, it has to split. So part of the current will flow on this branch. Some will also flow on this branch. Some will also flow on this branch. And the remaining also will flow on that branch. But that branch current was given to the I naught. So let's say the current on this branch, let's name it what? I1. Let's say this is I2. This is what? I3. And the current on this branch is what? I naught. So we can apply the idea of what KCL, Kirchhoff's current law. That is the sum of current entering a junction is equal to what? The sum of currents leaving that particular junction at the same time. At a particular moment, the sum of currents entering is equal to what? The sum of currents leaving. So let's apply KCL at junction or node. Node what? A. Let's call this junction what? Junction A or node A. So Ix is entering. So the sum of the current Ix from KCL, Ix is equal to what? The sum of the current leaving this junction, which is I1 plus I2 plus I3 plus I naught. So I1, I2, I3, and what? I naught. These are, or this represents what the KCL for this network. But we know that from Ohm's law, I is equal to V over R. And whenever a current flows through a resistor, there will be a voltage drop across the resistor. Alright, so if this I1 is flowing through these 8 ohms, there will be a voltage drop across the 8 ohms. Let's call it V1. I2 through this one will give us V2. Let's name this one V3. I naught through this one, let's name it what? V naught. So we can express each of the I here in terms of what? V over R. So Ix is now equal to what is I1? I1 is V1 over 8. So V1 over 8 plus I2 is what? V2 over 8 resistance. I3 is V3 over the resistance plus what is I naught? V naught over resistance what? 16. We were not given V1, V2 and V3, but we can calculate V naught from Ohm's law. V naught is equal to I times R. So from this one we know that V naught is equal to the current I naught times the resistor, which is what? 16. That will give us the voltage across the 16. And we know this is what I naught was given to be 3 by 16, and this is what? 48 volts. So the voltage across the 16 ohms is 48 volts. How then can we calculate V1, V2, and V3? We know that these 4 elements, 1, 2, 3, 4, are connected in parallel. And elements in parallel have the same characteristics. Elements in parallel have the same voltage characteristics. The voltage across them is what? Equal. So if we know the voltage for one of them, it means they will all have that same voltage. So we can conclude that our V1 is equal to our V2 is equal to V3 is equal to what? V naught, which is what? 48 volts, because they are in parallel. So they are all sharing the voltage across the 16. So we can substitute these values into our KCL equation, then find our Ix. That means our Ix is going to be what? V1 on 8, which is 48 on 8 plus V2 on 4. 48 on 4 plus V3 on 2. 48 on 2 plus 48 on 16. 48 on 8 is giving us 6. 48 on 4 is giving us 12. 48 on 2 is giving us 20 what? 4. And 48 on 16 is giving us what? 3. So let's get the summation of this. 6 plus 12 plus 24 plus 3 is giving us 45 amperes. And that is what? Our Ix. So the Ix in this circuit, that's the total current, is equal to 45 amperes. So now the next part of the question is to calculate the total power absorbed by what? The entire network. We have several formulas for calculating power. You know that power, when we are giving voltage and resistance, is equal to what? V squared over R. Power also is equal to what? P is equal to what? I V. Power is also what? I squared R. And in this diagram, we were not given total voltage, so we can't use this one. We were given total current, right? Ix, but we were not given what? The total voltage. Using this one, we were given total current, and we can as well calculate the total resistance in this network. So we would go with what? The I squared R. The I squared R to calculate for what? The total power. So total power is I S squared, the I total squared times the total resistance. So calculating the total resistance, let's assume the source is here, because we have our total current moving here. So there is a source here which is producing what? The current. So we have to start from the end of the circuit. So let's start from here. We know 16, 2, 4, and 8 are in parallel. Let's find its equivalent. Let's say 1 over RA is equal to what? 1 over 8 plus 1 over 4 plus 1 over 2, 1 over what? 16. And that one is giving us, we are finding the total resistance in parallel. So this is giving us 15 on 16 what? Ohms. That is 1 over RA. So it implies that our RA is equal to what? 16 on 15 ohms. The reciprocal of the 15 on 16. This is not the total. This is the equivalent of what? This portion. The equivalent. So our network looks like this. This is where we have what? The 10. And this is where we have the 16 on 15. So looking at this, we can see these two are connected in what? Series, because they are having the same current flowing through. So our total resistance RT is equal to 10 plus 16 on 15, which is giving us 16 on 15, which is giving us 166 over 15 what? Ohms. That's the total resistance. 166 on what? 15 ohms. So we can now use the power formula to calculate the power absorbed. So the total power PT, the total power PT is equal to Ix squared, which is 45 squared times what? The total resistance, 166 on 15, and that is giving us 22410 watts. Good. So the total power absorbed by the entire circuit is what? 22,410 watts, which is the same as 22.41 kilowatts. So that's it. That's the end of tutorial 3. Thank you very much for watching.